So we continue with the for loop, and with the for loop over here, this is the format. We have for and initialization before the condition, and then after that we have increase or decrease, right? So that's the format. Then after that we run a statement. If you don't get this, we would make an example and you will get what I mean over here, right? So this loop repeats the statement over here while the condition that was specified over here is true, right? So as soon as this condition becomes false, then whatever statements that follow will not be run, and the code would get out of the for loop and then continue with the rest of the code, right? So you would declare a variable and set it to an initial value. So condition is checked. Then after you set it to an initial value, then the condition is checked, and then you update it before you then execute the statement, right? So let's just go ahead and look at what we are talking about with an example. So I would illustrate with countdown when, okay, so this is an example, a line that I included so that I don't forget, right? So we are going to use the countdown example again. So we're going to count down to a shutdown, right? And we're going to use the for loop. So the first thing you want to do is to use the for keyword and into bracket whatever parenthesis, whatever is going to take three parameters. The first one is initialization, and we looked at how to declare and initialize variables in one line in a previous video. So that's what we'll be doing over here. We'll declare a variable, let's say int a, and initialize it to a value of, let's say, 10, right? So we have initialized this variable, and after that we have to use a semicolon because it's a full statement. This should take three statements: initialization, condition, and then increase. We have looked at statements and they end in semicolons. So this is going to be a statement. And then after that, what do we want? We want to count down. So if a is 10, how do we want to specify the condition such that it would work very well for us? So we want to specify that a should be greater than 0, then after that a semicolon, and then we then update the value of a, and that's going to be minus minus a, right? So this is the three conditions that we have inputted. This is the initialization, and this is the condition that is checked to see if a is true, to see if it's true, and if it's true, it goes ahead to run the statement that will follow, right? So we are now at the statement stage. So what we'll do over here is to put whatever we want the loop to do after the condition is true. So we just want to print out the countdown, right? And it's basically print a, right? So after printing a, let's say a seconds, that's what we used the other time. So a seconds to shut down, right? So let's just include this in case we'll be adding a second line, endl, right? So let me put a space here. So this is basically it. So let's run it to see what will happen, and let's put a code here to ensure that this code gets executed after this loop's ends. So let's just output cout the loop has ended, so that we'll be sure that if this line gets executed, then we are sure that our loop has ended, right? So endl. But before we want to run that line, we want to output a second line over here that your computer is shutting down, like we did the other time. And then after that, endl. Good. I think we're good to go. Let's run this and then we would explain further from the output. And now I have 10 seconds to shut down, your computer is shutting down. 9 seconds to shut down, your computer is shutting down, right? So this is not what we wanted, even though we have the 10 seconds to shut down and the countdown is what we wanted. But this line, repetitive line, your computer is shutting down, it shouldn't be here, because if it's here, it gets run every time. So we will put it outside of the loop. So I would cut this and paste it outside. Let me adjust this and we run this. Now we have the desired output: 10 seconds to shut down, 9 seconds to shut down, 8 seconds to shut down, 1 second to shut down, and the loop ended and this line was executed. So you know that this line was not executed um, until the time the loop ended, right? So when the loop ended, when the condition became false, when a became 0 seconds, then the loop ended. But when it was at a is equal to 1, a was still greater than 0, so the loop was running. But as soon as we decreased 1 by 1, and then a was then 0, then the condition became false and the loop shut down. And then we had to continue outside of the loop to run the other lines that come after the code, right? So, but we can see over here that we have something that is not desired, it's undesired. So 1 seconds to shut down. We want to modify this code to make it print 1 second to shut down, not 1 seconds to shut down. So what we can do over here is we can modify the statement that should be output, right? So we want to check if a is equal to 1, then what should happen? We want to output cout a second. Let me put a space over here. A second to shut down, right? And then after that, oops, endl, right? And then after that, else what do we want to do? Else just output this. So we cut this and paste it in there, and I think we're good to go. Let me rearrange this to make it good one over there, right? So I think this bracket does not have a counterpart, so we'll go ahead and put one here for it. Good. Now we run this to see what the output is going to be. So let me separate this, run it. Now we have 10 seconds to shut down and 2 seconds to shut down, 1 second to shut down, right? So that is a little modification that we made. And now note that we put the if over here. So at this point, when a is equal to 10 and the code checks to see if a is greater than 0, so 10 is greater than 0 and it's true. So it will go ahead and then minimize this by 1, and then the a will now be 9, right? So over here we checked if a is equal to 1, equal 1. 9 equal 1 is false. So since it is false, this code does not get run. It doesn't print 9 second to shut down because 9 is not equal to 1. So this will not get run. So else, so the condition what we did fell under else because 9 is greater than 1, is not equal to 1. So else output a seconds to shut down. So if it is 9, if it is 8, if it is 7, if it is 6, up to 2, since they are not all equal to 1. So at the point that a became 1, then this code was then executed, right? So basically that is the for loop, right? Let me see if I wrote something any other thing here. So I would illustrate with countdown when I is greater than 0, right? So this is what we used over here. Now I want to use another format where I is less than 10, right? So let's use another way. Let's initialize a to 0 and then a to be less than 10. I hope you get the syntax over here. So a is now going to start from 0 and then count up. So over here we make it count up. We update a by adding 1 1 till 9 because we want it to be less than 10. I hope you get the syntax over here. So if a equal 1 again, then I'll put 1 second to shut down, right? Or else I'll put this. So we run this to see what the effect is going to be. And we have an error over here. Whoops, there's an unwanted G over there. And this should be less than 10. And here we have it, 0 seconds to shut down, 1 second to shut down, 2 seconds to shut down, and up to 9 seconds to shut down. So your computer is shutting down, right? So the limit over here was 10 seconds, right? So that's it. But over here we have, so we can say if a equal 1, or we can use the or operator here, right? Or a equal 0. So we run this, right? and it's been corrected. So 0 second to shut down, 1 second to shut down, and all of that. So you can put conditions over here that you want and to just try things out. So basically that's the for loop. Right now, let's see if we have any other thing to talk about. Now, there is another case that we can do this, and this is what we'll be talking about right now. So let's say that I initialize A outside. This basically takes three parameters. It takes the initializer, it takes the conditioner, and then it takes the updater. Right. Now you can put this outside. So I'll cut this and then initialize it outside. And note that even though I did not include it here, the semicolon is still there. If it's not there, it's going to throw an error. So I initialize this with a semicolon over there, right? So then we run this and we should get the same output, right? And we have the same output over here. Now you should note that without the condition, it's going to run like an infinite loop, right? So let's delete the condition and leave the semicolon over there, because let's just delete it and run so that you guys will be sure that there is going to be an error, right? So we have to always have the semicolon over there because the computer is expecting three parameters. So this is the space for the first, this is space for the second, and all of that. So we run this again and it should be an infinite loop. So you can see that it keeps adding 1 1 1. Let's pause this. So it keeps adding 1 1 4 3 1 4 4 1 4 5, and it keeps going and going and going because we have not specified when it should stop. We have not specified when exactly the condition becomes false. So in this case, it keeps going and going, and it becomes an infinite loop unless we stop it ourselves. So that's why the condition is always important over here. So we go ahead and then we input the a less than 10 over here, and we run it to make sure that we have everything in place before we leave. Right, and we have everything in place, so we just go ahead and close this, and then the next thing, run with no condition, right? And this is an infinite loop, right? So now we looked at the use of the comma operator in a previous video, and we said it can be used in a place where one expression is generally needed, but then because we want to input two expressions in that particular place, we can use a comma to separate it, where we had int b to be equal to, we had a equal 5 comma, then we have a plus 10. We looked at this example, right, where we initialized a outside here already, int a, and then let me just space this all out, right? So in this case, there is an integer a there was a variable a that was declared, and then what happened here was we then initialized a to 5, and after that, since a was then 5, so a plus 10 was then assigned to b, so b will then become 15, right? So let's go ahead and run this to see what the output is going to be. So I'll just go ahead and comment out all of this so we don't get this one as well. So I'll go ahead and run this. Whoops, I did not even add a print statement. So let me just, so output a first, and then let's use a tab to kind of separate them. We don't want a new line. Then let's just use the semicolon. So shift B, and we should get 515, right? So 515, right? So that's how to use the comma operator. So over here, technically, we should be using one statement. We should equate b to, let's say, a plus 5. But because we wanted to use two expressions in place of one, we had to use the comma operator. So that was a quick recap over there. So I'll go ahead and uncomment this so we can use this code. So over here as well, in the initialization aspect, we can use two expressions separated by a comma. And then in the updating aspect, we can use two expressions separated by comma. So how do we do this? Now I'll just go ahead and copy this and then paste it over here. So now this is our new for loop. And what does this do here? It says that for int n is equal to 100, and then I is equal to 0. And note where the semicolon is. The semicolon comes here. And at the first, this place should carry just an initializer. But in this case, we are initializing two variables, n and I. And they are all integers, so you don't need an excess integer over here, int keyword over here. So n is equal to 100 and I is equal to 0. Then this code between the two semicolons is what we call the condition. And the condition is that n should not be equal to I. So as far as n is not equal to I, then continue to run the following code. If n is equal to I, then you have to get out of the loop. Right. Then after that, we put in the updating values. So we want to subtract 111 from n in every step, and we want to add 1 to every I in every step. So then let's output this to see what it's going to be. So I'll just go ahead and let me comment this out. Right, I think we'll be using it later on, but I don't want to delete it. So I'll go ahead and comment this out, and then to just this place over there. So then what do we do over here? If this happens, we want to just print out n, and I want to use a tab here as well. We don't want a new line, so tab I. Right, so let's just go ahead and see what this is going to output by running shift B. Now we have 100 0, 99 1, 98 2. So now we initialized n to 100 at first, so n was 100 over here, and I is 0, I is 0. And now the condition is as far as n is not equal to I. And if you check here, these values, none of the left column values are equal to the right hand values. None of them are equal, they are all different. So the condition was met as far as the loop was concerned. Then to the updating, you can see that in every turn, in every step, the value of n was reduced by 1. So 100, 99, 98, 97, it was reduced. But then the value of I was increasing. So 0, 1, 2, 3, 4, 5, right. So n was reducing up till 51, and I was increasing up to 49. The next step would have been 50. The next step would have been 50 for here, because this would reduce to 50 and this would increase to 50. So at that particular point, n would be equal to I, and the condition became false. Since the condition became false, then the loop was shut down, and the code execution stepped out of it and then started executing the next lines. So if there were several lines of code over here, all of those ones would continue executing. Right, so that is it for using the comma operator to substitute in two expressions in place where you needed one parameter. Right, now let's go ahead and modify this particular code. So let's say that we just want to print the even numbers. So we can say if, with a condition, if n mode 2, right? If n mode 2 is equal to 0, right? Then you should go ahead and then output n and all of that. Else, I don't think we should even put any else there. So let's just run this to see what's going to happen. Right, so now we have all the even numbers. So it first increased the value of n by, it first reduced the value of n, became 99, and then it checked, is 99 divided by 2 equal 0, and it's not true, so it skipped that one and came to and came to 98, because 99 minus 1 would give us 98, and it's 98 divided by 2 mode 2 equal 0. Yes, it's equal 0, and that was output, and it did same for the I as well. So it's kind of concurrent. You do this for n and you do this for I. Right, so that's it for the comma operator in for loops. So we move on to the next section, and it's range based for loop.